What if everything we see, the galaxies, the stars, the atoms that make up your body, is only the surface of something far greater? What if the visible universe, with all its brilliance and motion, is just the faint vibration of a deeper reality, a silent structure beneath existence itself? Physicists have spent a century peeling back the layers of matter. They've discovered quarks and leptons, gluons and bosons, fields and symmetries, each revealing a little more of the machinery beneath the world we know. And yet something is still missing. Something vast and invisible. The universe does not add up. Galaxies spin too quickly, their stars flung outward as if by unseen hands. Clusters of galaxies bend the light of distant quasars, shaping space itself with invisible mass. Even within our own Milky Way, stars move as though pulled by something colossal, something not made of atoms or light. We call it dark matter, not because we understand it, but because we do not. And perhaps within that unseen realm, there lies a single ghost-like particle that could explain it all: the axion. The axion is one of the strangest ideas in modern physics. A particle so light, so weakly interacting, that it slips through the universe unnoticed. Trillions could be passing through you right now, through the air, through the earth, through the heart of the sun, and you would never feel them. They do not glow, they do not scatter, they do not collide. They simply exist, quietly, perfectly, invisibly. It sounds like fiction. But the axion wasn't born from imagination. It was born from embarrassment. In 1977, two physicists, Roberto Pecci and Helen Quinn, noticed a flaw in the equations that describe the strong nuclear force, the fundamental interaction that glues atomic nuclei together. In those equations lurked a hidden parameter, one that, according to the laws of quantum mechanics, should break a delicate symmetry between matter and antimatter. If that symmetry were broken, neutrons would carry a faint electric imbalance, a tiny distortion measurable in the lab. But when scientists looked, they found nothing. The neutron's electric dipole moment wasn't small. It was nearly zero, so small it defied explanation. Nature had somehow cleaned its own equations. This was the strong CP problem, one of the most haunting inconsistencies in all of physics. Why would the laws of nature allow asymmetry, yet the universe refused to display it? Why would reality be so unnaturally perfect unless something deeper enforced that perfection? Pecci and Quinn proposed an answer that was as bold as it was elegant. Perhaps the universe contains an invisible field, one that constantly adjusts itself to erase this imperfection. A kind of quantum feedback loop that smooths out imbalance, ensuring that the equations of the strong force remain spotless. That field, they suggested, would give rise to a particle, a vibration within it. That vibration would be the axion, and the axion, by its very nature, would be nearly invisible. It would interact so weakly with ordinary matter that detecting it would be almost impossible. It would be, in every sense, the ghost of the quantum world. The name axion came from a brand of laundry detergent. It was a joke, a particle that would clean up physics. But the humor disguised something profound. The axion was not just a mathematical convenience. It was a key that might unlock both the smallest and largest mysteries in the universe. For if axions truly exist, they would have filled the cosmos since the beginning of time. In the first moments after the Big Bang, the axion field would have rippled and cooled. Its vibrations would have crystallized into particles, forming a vast, invisible ocean of matter, cold, silent, eternal. This ocean would have shaped galaxies, slowed their rotation, sculpted the cosmos itself. It would be the dark matter we have been searching for, the missing 85% of the universe's mass. A particle invented to explain a flaw in quantum mechanics might also explain the architecture of galaxies. The same principle that keeps the equations of atomic nuclei clean might also hold the cosmos together. A correction in mathematics could be the very scaffolding of creation. Consider that. The same silent force that prevents the neutron from twisting may be the one that prevents the universe from collapsing into chaos. The axion is more than a hypothesis. It's a philosophy written in mathematics, a suggestion that the universe corrects itself, that nature, at every scale, seeks balance. Perhaps the axion is the physical manifestation of that instinct, the universe's built-in conscience, ensuring that imperfection never becomes irreversible. If so, then the cosmos is not merely governed by chance. It is self-healing. And that idea transforms everything. Because it means the invisible is not empty. It is alive with purpose. The silence of space may not be silence at all. It may be the hum of equilibrium, the echo of a field that has been resonating since time began. To find the axion is to find the fingerprint of cosmic morality, the proof that reality, left alone, will always seek to right its own wrongs. Across the world, scientists have devoted their lives to listening for that hum. Deep beneath mountains, in cryogenic laboratories, enormous magnetic fields twist through vacuum chambers as detectors strain to hear a single photon that should not exist. The ADMX experiment in Washington, CAST at CERN, Haystack at Yale. They are tuning their instruments to the quietest frequency in the universe. They have not heard it yet, but they are getting closer. Perhaps when they finally do, it will not sound like thunder. It will sound like revelation. Because somewhere between matter and meaning, between equations and existence, there lies a single vibration that connects them all. The axion, a particle so small it can never be seen, a field so vast it may never end, a whisper that keeps the universe in tune. And perhaps it has been playing all along. Next, we descend into the mathematics themselves, to the unclean equation that first demanded correction, and the silent perfection that gave birth to the axion. The universe, for all its elegance, was never meant to be this perfect. Every force we know, gravity, electromagnetism, the weak and strong nuclear interactions, arises from deep symmetries written into the mathematics of reality. But symmetry in nature is fragile. It breaks. It must break, or there would be no stars, no matter, no life. When symmetry fails, the universe becomes creative, yet sometimes it fails too perfectly. Deep within the equations that describe the strong nuclear force lies a term so small, so precise, that it seems almost supernatural. This is the theta term of quantum chromodynamics, the mathematical fingerprint of potential imperfection. It describes how quarks and gluons, the building blocks of matter, might subtly prefer one orientation of charge and parity over another. In theory, this term should cause neutrons to possess an electric dipole moment, a tiny imbalance of positive and negative charge within the particle's core. It would mean that even the smallest fragments of matter carry a whisper of asymmetry, a faint reminder that the universe, at its roots, is not entirely fair. But when physicists measured it, the result was almost zero. Not small, not diminished, zero to a precision so extreme that it mocked belief. The universe had erased its own imperfection. To grasp how improbable this is, imagine tuning a dial with 200 trillion possible settings, only to find it resting exactly, impossibly at zero. The odds are cosmic, the precision divine. This, then, is the strong CP problem. The CP stands for charge and parity, two symmetries that describe how the laws of physics behave when the universe is mirrored or when matter becomes antimatter. In the realm of the weak force, those symmetries are broken routinely. Yet in the strong force, the one responsible for binding the atomic nucleus, they are perfectly preserved. Too perfectly. The strong CP problem became a wound in the heart of theoretical physics, a mystery that logic could not heal. Why would the universe allow the term to exist, yet forbid it to act? Why grant imperfection only to erase it with unearthly precision? It was as if nature had built an imbalance only to hide it from itself. Some suggested coincidence, others invoked chance. But chance rarely fine-tunes itself across 30 orders of magnitude. Roberto Peccei and Helen Quinn refused to believe the universe would rely on luck to maintain such order. They proposed instead that there must be an unseen principle at work, a hidden symmetry that the equations themselves could not yet express. Something elegant, something corrective. Their idea was deceptively simple. If the theta term causes imbalance, then let there be a mechanism that forces it toward balance. Let nature, through its own mathematics, clean itself. They introduced a new global symmetry, now called the Peccei-Quinn symmetry. When this symmetry breaks spontaneously, it gives birth to a new field, an ocean of quantum potential stretching through all of space. Within that ocean, the parameter theta does not remain fixed. It flows, adjusts, and relaxes until the imbalance vanishes. And when a field moves, it vibrates. Each vibration, each tiny oscillation within it, manifests as a particle. That particle is the axion. At first, it was only theory, a hypothetical note added to the symphony of physics to resolve a single discordant tone. But in that correction lay something extraordinary. By stabilizing the strong force, the axion could also explain why the universe itself remains stable. It would mean that imperfection is not eliminated by accident, but by design, that the universe does not merely happen to be balanced, it insists on being balanced. The implications ripple outward like waves in a dark pond. If such a field exists, it must permeate everything. The same invisible fabric that cleanses the equations of the atomic nucleus must also weave through galaxies, stars, and the void. The same mechanism that erases a quantum blemish might also sculpt the gravitational skeleton of the cosmos. What began as a correction inside the heart of matter could extend to the edge of the universe itself. Peccei and Quinn had not only repaired a flaw in theory, they had revealed a hidden morality in physics. A tendency for nature to restore what is broken, to smooth what is rough, to find equilibrium in chaos. It is a principle that feels less like mechanism and more like intention. Some physicists resisted the elegance of the idea. They called it unnecessary, speculative, even theological. But history is written by equations that refuse to stay ugly. The Peccei-Quinn symmetry was not just beautiful, it was necessary. And beauty in physics has a strange way of being true. The axion became the embodiment of that truth. Invisible, corrective, everywhere. Its existence would mean that symmetry is not a condition, it is a living process. The universe is not balanced because it was made that way. It is balanced because something keeps it that way. In a single act of mathematical redemption, one field had turned chaos into order, noise into harmony, imperfection into perfection. The strong CP problem was no longer a wound, it was a window. Through it, physicists could glimpse a universe that polices its own integrity. Perhaps the axion is not merely a solution, it is the law behind all solutions, the pulse beneath the equations, the silent urge toward balance. If that is true, then every stable atom, every symmetrical form, every unbroken pattern in existence is the echo of that same hidden correction, a universe quietly cleaning itself of chaos, one vibration at a time. Next, we follow that vibration beyond theory, into the particle that should not exist, yet may define everything that does. It began as a whisper in mathematics, an afterthought, a byproduct of a symmetry too perfect to be real. No one expected the axion to exist outside of paper. It was born not of observation, but of necessity. A theoretical repair, a footnote in the margins of quantum chromodynamics. And yet, from that mathematical correction, something astonishing emerged. A new kind of matter that defied the ordinary categories of the universe. To understand the strangeness of the axion, you must first imagine the landscape of particles we already know. Every fundamental particle fits into one of two great families, fermions and bosons. Fermions, such as electrons and quarks, are the matter makers. They build the universe's architecture, obeying the exclusion principle. No two can exist in the same quantum state. Bosons, like photons and gluons, are the mediators, the messengers of force. They bind, carry and translate the interactions between the fermions that build everything we see. But the axion is different. It is not a mere mediator of force nor a builder of matter. It is something subtler, quieter. A pseudoscalar boson, a particle whose very existence violates the simplicity of our categories. It has no spin in the conventional sense, no charge, no color. It does not participate in the vibrant exchanges of ordinary particles. It floats through them like a thought through a crowd, undetected, undisturbed, yet somehow aware. In theory, the axion's mass depends on a hidden scale known as the Peccei-Quinn energy, denoted by F sub A. The higher this energy scale, the lighter and weaker the axion becomes. At the limit, it approaches invisibility itself, a particle that barely exists, yet whose existence changes everything. At first, this was a paradox too great for belief. How could something so faint have such power? How could a ghostly ripple in a field control the symmetry of nuclear forces, influence the rotation of galaxies, and remain unseen? And yet the universe often hides its grandest truths in its faintest voices. The axion is not violent. It does not collide or shatter. It persuades. It seeps through the fabric of space, adjusting, balancing, harmonizing. It is the quiet diplomat of physics, the one that reconciles disagreements no one else can see. Mathematically, it arises as the goldstone boson of the broken Peccei-Quinn symmetry, a vibration left behind when the symmetry collapses. But because this symmetry is not perfect, the axion gains a small mass, tiny but real. It oscillates softly, a standing wave in the vacuum, its energy dispersed across the entire universe. In the quantum world, such vibrations never die. They persist, infinite in duration, their frequencies etched into the fabric of reality. The axion field, then, is not confined to particles. It is a medium, a background hum to existence. It fills the void between galaxies, threads through the magnetic fields of stars, and perhaps even passes through you in this very moment. If you could somehow tune your perception beyond matter, beyond light, beyond even gravity itself, you might feel its rhythm, a vibration so low that it would seem like silence. Yet that silence is the foundation upon which everything else rests. The axion is the particle that should not be. It was never predicted by nature, only by necessity. And yet its properties align with the greatest unfulfilled prophecy in modern physics, the nature of dark matter. Consider what makes dark matter so mysterious. It interacts gravitationally, it has mass, but it refuses to emit or absorb light. It is cold, slow, and omnipresent, influencing the formation of galaxies and the structure of the cosmos itself. For years, scientists have searched for dark matter candidates, massive neutralinos, sterile neutrinos, exotic WIMPs, but each has failed to appear. Each experiment has come back with nothing but deeper uncertainty, and then someone realized the axion fits. It fits perfectly. Its interactions are feeble enough to make it invisible, its mass light enough to remain stable since the birth of time, its abundance sufficient to account for the missing mass of the universe. The very qualities that made it absurd as a particle make it ideal as a cosmic solution. If the axion exists, then the universe is filled with it, an ocean of invisible substance pressing against everything we know. Galaxies are not bound by dark halos of exotic particles, but by the slow undulations of an all-pervading field. Every star, every planet, every breath is adrift in that unseen sea. And yet this revelation comes with a kind of humility, for the axion's existence would mean that the universe's deepest mystery was not a grand hidden power, but a whisper of balance, not a roaring force, but a gentle correction, the quiet triumph of order over chaos. Physicists once imagined the universe as a clockwork machine, a place of collisions and reactions, of energy and momentum, of explosions and collapse. But the axion paints a different portrait. The cosmos, it suggests, may be more like a self-tuning instrument, forever adjusting itself toward harmony. In this view, the axion is the unseen musician, the conductor of symmetry, ensuring that every note of creation remains in key. It is neither good nor evil, neither conscious nor blind. It simply is. The embodiment of the universe's preference for balance. And if this is true, then perfection itself is not an accident. It is an emergent property of existence, a law as real as gravity, hidden beneath the surface of all that is. The particle that should not be may, in the end, be the one that makes everything possible. Next, we follow the axion beyond the equations, out of the quantum realm and into the dark architecture of the cosmos, where invisible matter sculpts the galaxies and the ghost of symmetry becomes the skeleton of the universe. Look up at the night sky, and what you see is an illusion of fullness. Thousands of stars glitter across the black, bright islands adrift in a cosmic ocean. Yet for all their brilliance, they are only traces of something vaster, something hidden. 95% of the universe's true substance does not shine, does not scatter light, does not reveal itself. The visible cosmos is merely the foam atop a deeper sea. For centuries, we believed that the stars were the story, that their light defined reality. But now we know that light is a minority voice in the universe's great chorus. The rest, the dark matter, is silent. It neither burns nor reflects. It is not gas, nor dust, nor faint starlight. It is something else entirely, invisible mass, invisible gravity, invisible structure. Without it, galaxies could not exist. Their stars would spin outward into the void, torn apart by centrifugal force. Their shapes, their spirals, their very persistence, all of it depends on this unseen scaffolding. Dark matter is the architecture of everything we see, the skeleton upon which the luminous flesh of the universe is draped. And the axion, small, elusive, nearly non-existent, may be that skeleton's bone. If trillions upon trillions of axions were created in the first fractions of a second after the Big Bang, they would have behaved unlike any ordinary matter. They would not collide, nor clump, nor ignite. They would cool with the universe itself, their motion slowing until they became what physicists call cold dark matter. Cold, not in temperature but in speed, moving sluggishly enough to allow gravity to draw them into halos around galaxies. These halos, invisible yet immense, stretch far beyond the reach of visible light. They are the unseen boundaries of galaxies, shaping every star's orbit. Each galaxy, including our own, floats within its own dark cocoon of axion-rich space. Imagine it. The Milky Way surrounded not by emptiness, but by an ocean of whispering fields. The stars that we see are only ripples on its surface, glowing islands suspended in an invisible tide. Every rotation, every gravitational embrace, every beam of light bending through interstellar space, all of it choreographed by the unseen weight of axions. And we are inside that ocean, always. Every particle of your body is adrift in it, swaying gently with the cosmic current. We move through it as fish through water, unaware of the medium that sustains us. This idea that something so intangible could define everything feels paradoxical, almost metaphysical. A universe dominated by what cannot be seen, built upon matter that refuses to acknowledge us. But perhaps invisibility is not absence. Perhaps it is the truest kind of presence. For decades, scientists have struggled to see the unseeable. They've mapped the shapes of galaxies, measured how their stars move, calculated the gravitational tug of the unseen. Everywhere, the evidence points to the same truth. Whatever dark matter is, it outweighs all visible matter by a factor of 5. It shapes the universe's evolution, dictates its fate, and yet remains silent. In that silence, the axion seems to fit too well. Its properties, light, stable, undetectable, are not a coincidence. They are exactly what the cosmos requires. The particle invented to fix a flaw in quantum equations now appears to fill the heavens. The humble correction to the strong force may also be the missing mass of creation. It is poetic, even unsettling, that the universe's stability arises not from strength, but from stillness. If axions truly make up dark matter, then they are not scattered grains drifting through space. They are a vast coherent field, a slow oscillation of the vacuum itself. This field, vibrating across billions of light years, would behave like a single cosmic organism, moving as one. It would be less a sea of particles than a continuous tone, a standing wave resonating through space-time, and that tone has never stopped playing. Every moment, every second, the axion field hums through galaxies, through planets, through us. The universe is not silent, it is singing beneath our perception. The galaxies spin not by chaos, but by rhythm. Every motion is a chord in the same invisible harmony. This is the ghost of matter, not a haunting, but a hidden order. If axions exist, they are the medium in which all things move, the unseen current that carries stars like leaves. Their gravitational pull, though faint, defines the geometry of everything. They are the map and the mystery, the invisible handwriting of the cosmos. In them, we find a lesson about existence itself, that what matters most may be what cannot be seen. That reality is not confined to the luminous, the tangible, or the loud. It is written equally in the quiet, the transparent, the humble. The axion reminds us that creation does not need to shout, it hums. And yet, the deeper we chase this ghost, the more questions it raises. If axions make up the universe's hidden mass, then how can something so ethereal shape the structure of everything we know? How can something that never touches us define our reality? To answer that, we must descend once more into the mathematics of fields, into the lattice of the unseen, where geometry and symmetry intertwine, and where the axion reveals not just what it is, but what it means. Reality, for all its chaos, is built on a hidden order. Beneath the galaxies and the particles and the heat of the stars, there is a framework more fundamental than atoms, more enduring than space itself. The universe, when stripped to its bones, is not made of matter. It is made of fields. Every particle we know is not a thing, but a vibration, a localized ripple within a deeper field. The electron is a wave in the electron field. The photon is a tremor in the electromagnetic field. Even the Higgs boson, the so-called God particle, is nothing more than the brief awakening of the Higgs field. And now, to explain the invisible architecture of the cosmos, we invoke one more, the axion field. It is not like the others. It does not crackle or shimmer or explode into energy. It drifts, it hums, it permeates the universe like an ocean of stillness, vibrating so slowly that it appears motionless. If you could see it, space itself would look like a fine lattice of tension lines, stretching infinitely in every direction, each one pulsing softly, 1 billion times a second, though you'd never know. The axion field is a self-balancing system. It wants equilibrium. It resists imperfection. And so when the universe was young, when all was heat and turbulence and collapsing symmetry, the axion field began to act. It sensed imbalance in the strong nuclear force, in the misalignment of charge and parity, and began to restore it. Mathematically, this is the Petit-Quinn mechanism at work. Physically, it is as if the universe grew a conscience. At every point in space, the axion field sought to minimize its potential energy, to find the smoothest, most symmetrical state possible. But in a universe expanding faster than light, that process could not occur uniformly. Different regions froze at different values, leaving faint wrinkles, imperfections across the field, a kind of cosmic scar tissue. These wrinkles, tiny as they were, gave rise to axions, minuscule vibrations left behind when the symmetry solidified. They were born in abundance, incomprehensible numbers of them, light as thought and cold as silence. They spread everywhere, forming the invisible framework that would later guide galaxies into existence. And this framework, the axion field, is not passive. It continues to oscillate, like a bow drawn slowly across the strings of space-time. Its frequency depends on the particle's mass. Lighter axions vibrate slower, heavier ones faster, but all of them together compose a symphony of invisible motion interwoven across the universe. It is, quite literally, the lattice of the unseen, the gridwork of stability on which the cosmos is built. In quantum chromodynamics, this behavior is expressed through the theta term in the Lagrangian, a small parameter representing potential CP violation. The axion field dynamically drives theta towards zero, cancelling the violation, restoring perfect symmetry. But such language cannot capture the poetry of it, the image of a universe fine-tuning itself, forever seeking balance, as though perfection were not an accident, but a law. To an observer within this field, say to us, the axion's influence is subtle but profound. It modifies how light behaves in magnetic fields. It affects how stars cool, how galaxies rotate, how space itself curves under gravity. It whispers through everything, everywhere. But because it interacts so weakly, we mistake its silence for absence. Imagine standing inside a cathedral whose architecture you cannot see, only feel. The vaulted ceiling above you holds the structure's weight, but it is invisible. You sense it only through the echoes of sound, the distribution of stillness. The axion field is that ceiling, a presence defined by what does not collapse. And in that quiet balance lies something almost moral. Every other field in physics allows imbalance, chaos, decay. But the axion field forbids it. Its very nature is to erase asymmetry, to cleanse what is broken. It is the mathematical embodiment of correction. The universe does not tolerate imperfection. It corrects itself invisibly, perpetually, through this field. That is why some physicists call the axion the symmetry's revenge. But such self-correction comes at a cost. When the universe cooled and the axion field crystallized, those imperfections, the wrinkles, did not vanish. They stretched into cosmic strings, topological defects that may still thread through the cosmos today. Imagine filaments thinner than a proton, yet longer than galaxies, vibrating faintly in the dark. If such relics exist, they are fossils of the moment when symmetry broke and was born again. Some simulations suggest that these strings could form a network across the universe, intersecting, twisting, snapping, releasing bursts of axions like droplets from a vibrating web. It would be a cosmic harp, endlessly plucked by gravity, its notes inaudible but real. In this way, the axion field is both the healer and the historian of creation. It preserves the record of imbalance while maintaining the illusion of perfection. Every atom, every equation, every stable symmetry carries within it the memory of that ancient correction. The axion field, by cleansing the universe, became its foundation. And yet it remains invisible, an unspoken geometry behind all visible things. We sometimes speak of the universe as a mechanism, a grand machine of particles and forces. But perhaps it is closer to a work of art, an abstract canvas painted in frequencies and fields. The axion is not the brushstroke, but the texture beneath the paint, the hidden layer that gives depth to what we see. In the laboratories of today, physicists try to recreate this hidden structure. They design experiments that exploit the axion's coupling to light, its ability to convert into photons in the presence of strong magnetic fields. In essence, they are attempting to make the invisible lattice shimmer for a moment, to catch the glint of a photon born from nothing. To detect such an event is to touch the unseen architecture of reality. It is to see for a heartbeat the scaffolding behind existence. And if the axion field is ever directly observed, it will not simply add another particle to the catalogue of physics. It will rewrite the relationship between what is visible and what is real. It will show that the invisible is not beyond matter. It is the blueprint of matter. It will confirm that the universe is not made of things, but of corrections. That every structure, every balance, every law we hold sacred is not fixed, but continually rewritten by the unseen lattice that underlies it. The cosmos, it turns out, is not a static creation. It is a living equation, endlessly solving itself. And the axion, the quietest of all participants, may be the proof that the universe is aware of its own imperfections and determined never to let them stand. Next, we turn to the duality within this invisible world, the two competing visions of the axion, each with its own fingerprint on the cosmos, each revealing how many ways the unseen can manifest. When physicists first tried to give the axion form, they found themselves confronted by two reflections of the same ghost. The mathematics had revealed its existence but not its nature. It was as though the universe had whispered a word, and the meaning of that word split in two. Two models, two visions, rose from the equations, both elegant, both incomplete, both claiming to describe the same silent truth. They would come to be known as KSVZ and DFSZ, the twin faces of the invisible. The first, the KSVZ axion, was born from the work of Kim, Schiffman, Weinstein, and Zakharov. It is austere, minimal, a design of quantum economy. It couples to heavy, unseen quarks, ghostly particles that live only in theory, while ignoring electrons and light. The KSVZ axion is the introvert of physics, existing almost entirely apart from the visible world, hiding in the deep undercurrents of nuclear matter. The second, the DFSZ axion, from Dine, Fischler, Srednicki, and Zhitnitsky, takes a different path. It reaches out to ordinary particles, to electrons, to light quarks, even to photons themselves. It is a bridge between the hidden and the seen, a faint translator between the two languages of the universe. Each model carries the same mission, to correct the symmetry of the strong force. But they do so through different geometries of interaction, different balances of invisibility. One hides completely in the dark, the other leaves a fingerprint on light. In truth, these are not two particles, but two philosophies. The KSVZ model envisions a universe where the unseen dominates, that the truest things are those that never touch us. Its axions are isolated monks of matter, influencing reality only through gravity and the quiet push of quantum fields. If they fill the cosmos, we will never know them directly. They are the silence beneath creation, the backbone of galaxies we can never sense. The DFSZ model, by contrast, believes that the invisible must leave a trace. Its axions interact weakly with photons, allowing for the possibility of detection. They are still ethereal, still humble, but they glow faintly at the edges of perception, like dust caught in sunlight. Two theories, two kinds of faith. For nearly 50 years, physicists have debated which face of the axion, if either, belongs to the universe. The data, as always, are ambiguous. Some experiments whisper of light-sensitive axions, others demand the silence of the hidden kind. Each new result seems to erase the last, as though the particle itself delights in keeping us uncertain. And perhaps that is fitting, because the axion, whatever form it takes, was never meant to be simple. It exists at the boundary between contradiction and truth, born from a need to reconcile what cannot be reconciled. It is both visible and invisible, present and absent, particle and field. The two models merely mirror that paradox, two interpretations of the same mystery. There is something profoundly human in this duality. Throughout history, we have divided knowledge into opposites, the seen and the unseen, the body and the soul, the measurable and the ineffable. Yet the universe resists such divisions. It is both wave and particle, both void and energy, both chaos and order. The axion's dual nature reminds us that truth is not singular. It is an interference pattern, two possibilities overlapping until we look. Perhaps that is why no one has found it yet. The moment we try to force it to be one thing or the other, it slips back into ambiguity, like light refusing to choose between beam and wave. In the equations, these two faces of the axion behave differently. The KSVZ variety, coupling to heavy quarks, contributes mostly to hadronic physics, its presence detectable only in neutron experiments or deep stellar processes. The DFSZ axion, coupling to electrons and photons, opens a path to astrophysical detection, stars losing energy faster than expected, white dwarfs cooling in ways no standard model can explain. In their own quiet ways, both kinds leave faint signatures on the cosmos, and in those signatures we begin to see the scope of their influence. If KSVZ axions dominate, the universe is governed by absolute stillness, a dark matter of perfect detachment. Galaxies would move within invisible shells of pure inertia. Light would never betray their presence. If DFSZ axions rule, then the universe would shimmer faintly with invisible conversions. Every strong magnetic field, from neutron stars to the sun's corona, would act as a translator, turning axions into photons and back again. The cosmos would whisper through these exchanges, an unseen conversation between light and matter. Both models predict a universe filled with unseen grace. Both align with what dark matter demands. And both, in their different ways, suggest that the universe is not just governed by equations, it chooses harmony. When one looks at the equations that define them, the difference seems small, terms of coupling strength, logarithmic hierarchies, suppressed constants. But in those tiny details lies the fate of everything. The exact way in which the axion touches the world determines how galaxies form, how stars cool, even how long the universe will remain stable. And this too is a reminder. Reality's destiny often depends not on violence or explosion, but on the faintest whisper of connection. Somewhere between KSVZ's silence and DFSZ's faint radiance, the true axion may dwell, neither entirely hidden nor fully revealed, but balanced between. That balance feels familiar. We too exist between extremes, knowing and not knowing, seeing and believing. The axion in its duality mirrors our own condition. It is physics' reflection of consciousness, the search for truth that forever slips beyond definition. Whether it hides within matter or dances with light, whether it speaks only through gravity or hums faintly through photons, the axion remains one idea given two forms: the embodiment of correction, the instrument of balance, the bridge between what is seen and what must remain unseen.
And so the quest continues, not to choose between them, but to listen more deeply, to hear which note of the invisible symphony the universe prefers to play.
Next, we will follow that note back to its origin, to the early universe itself, where fields froze, symmetries shattered, and the axion's whisper became the first echo of order rising from the chaos of creation. Long before the first stars ignited, before galaxies swirled, before even atoms could exist, the universe was a storm of light and heat. Time itself was barely measurable, space was formless, and all the symmetries of nature, the laws that govern what can and cannot happen, were breaking and rebuilding in an instant. In that ancient chaos, something subtle stirred. While the young universe expanded and cooled, one field among countless others began to ripple with purpose. It was smooth and silent, stretching everywhere at once, a sea of potential energy without direction, without motion. This was the axion field, the whispering medium from which the invisible would be born. At first, it was in perfect equilibrium, but perfection is a fragile thing. As the temperature of the cosmos plummeted, the axion field began to freeze, not all at once but unevenly, different regions of space choosing slightly different values, like a sheet of ice forming across a turbulent sea. In each tiny patch of the universe, the field settled at a random phase. Each patch carried its own subtle tilt, its own whisper of a symmetry. These frozen variations were the seeds of everything to come. The universe was young, but already it remembered imperfection. When the cosmos cooled below the Pechiquin energy scale, the symmetry that had once allowed the axion field to roam freely shattered. The field no longer drifted effortlessly. It became locked to specific points, its oscillations confined. Those trapped vibrations became axions, real physical particles, each one a tiny echo of the field's frozen imbalance. To describe this moment is to describe a kind of cosmic awakening. From a single idea in mathematics, a new substance had emerged, light as breath, invisible as thought, and yet destined to shape galaxies. In the silence after the Big Bang, the axion field began to oscillate. Slowly at first, then rhythmically, like the after-ring of a struck bell. Each vibration corresponded to the creation of more axions. They filled the universe not as flashes of energy, but as a vast uniform background, a soft hum permeating all of existence. And that hum never stopped. Today, those same oscillations may still be moving through space, their frequency set by the axion's tiny mass. They have grown cold, cosmologically cold, meaning not slow by temperature but stable, timeless, indifferent to the passage of eons. They no longer react to the world, they define it. This is what physicists call the misalignment mechanism, the process by which the early universe's imperfections give birth to an invisible ocean of dark matter. To understand it is to glimpse how beauty hides in error. The axion field's initial imbalance, its misalignment from perfect symmetry, became the source of all invisible structure. Without that misstep, there would be no dark matter, no galaxies, no cosmic architecture. The very flaw the axion was created to erase became the foundation of everything we see. That irony is not lost on the physicists who chase it. The universe, it seems, corrects itself, not by eliminating mistakes, but by turning them into creation. If we could visualize the axion field today, we might see it as a shimmering lattice across the cosmos, a faint mist of quantum vibrations rippling through the void. Every cubic centimeter of space could contain billions of axions drifting in a slow collective motion, their waves overlapping, their energies merging into a single vast coherence. It is this coherence that makes the axion so extraordinary. Unlike ordinary matter, which moves in chaotic independence, the axion field moves as one. Across galaxies, across light years, it oscillates in perfect unison, like a chorus of unseen singers holding the same note. In some regions, gravitational tides have amplified these waves, drawing them into halos around galaxies, cold, dense clouds of invisible order. These halos are not static, they breathe. As they orbit the centers of galaxies, their density shifts rhythmically, creating subtle gravitational echoes that influence the movement of stars. Entire spiral arms may owe their shape to these slow oscillations. In theory, the Earth itself moves through this ocean every second, carried by the Milky Way's orbit. The planet's magnetic field, its atoms, even its vacuum, all swim within the axion tide. Trillions of them pass through your body every moment. You feel nothing, but they are there, flowing through you, as much a part of your existence as light and air. And yet, despite their abundance, the axion remains elusive. Because its interactions are so weak, it leaves no trace, no heat, no radiation. Its influence is indirect, seen only through the grand design of cosmic structure, the precision of starlight, the quiet persistence of galaxies that refuse to fly apart. It is the perfect paradox. A particle that cannot be found, but must exist, because without it, the universe makes less sense. There is a haunting symmetry in that. Just as the axion restores balance to the equations of the strong nuclear force, it may also balance the cosmos itself. The smallest correction in the smallest corner of quantum mechanics might have grown into the largest pattern in the universe. It is difficult not to see philosophy in such a pattern. The idea that from silence comes structure, from imperfection comes order, From the faintest vibration comes everything. The axion field becomes a metaphor for existence, a reminder that reality does not need to shout to be heard. Perhaps the universe does not create through explosion alone, but through resonance. Perhaps every act of being begins as a vibration in something unseen. In the first seconds of time, the axion field whispered into existence. It has never stopped whispering. The galaxies we see, the stars that burn, the atoms that think, they are all part of its ongoing note, sustained through eternity. The story of the axion is, in many ways, the story of stillness creating motion, the story of balance giving birth to structure. And now, after billions of years, humanity has begun to listen. We have built machines that cool themselves to fractions of a degree above absolute zero, magnets strong enough to bend space itself, detectors tuned to frequencies that never vary. We are trying to hear the whisper, the faint echo of that original field still humming through the void. But will we recognize the sound when we hear it? The axion's voice is not one of thunder or brilliance. It is the softest murmur imaginable, a correction, a balancing, a continuation of the first act of creation. It does not announce itself, it simply is. And perhaps that is the most profound truth of all. The universe did not begin with noise. It began with a whisper. Next, we turn from the cosmic to the human, from the universe's invisible music to the instruments we have built to detect it. For the first time in history, we are attempting to make the silence speak, to transform the axion's whisper into light. To find the quietest sound in the universe, one must first learn to silence everything else. The laboratories that search for axions do not resemble the gleaming control rooms of science fiction. They are temples of stillness, dimly lit caverns of metal and magnetism, buried beneath mountains or shielded from the chaos of human noise. Within them, the air hangs heavy, the hum of machines replaced by something stranger, an engineered quiet. For in these sanctuaries of precision, even the thermal agitation of atoms is an interference too loud to bear. Here, the temperature is colder than the vacuum between stars. Giant magnets curl around chambers of polished copper, superconducting circuits slumber in darkness, and antennas no larger than your hand are tuned to frequencies no ear could ever hear. What these instruments seek is not a flash, not a collision, not even a trace. They are listening for a conversion, the transformation of an axion into a photon, a single quantum of light born from silence. This is the essence of the haloscope, the device that listens for whispers in the electromagnetic field. The most famous of these is ADMX, the Axion Dark Matter EXPERIMENT, hidden deep within the University of Washington. Its heart is a microwave cavity, a metallic chamber surrounded by an immense magnetic field. The principle is delicate and almost poetic. If axions pervade space, then as they pass through this magnetic field, a tiny fraction may transform into photons, light coaxed out of nothing. The conversion is so weak that only the most sensitive detectors ever built could hear it, and even then, it would sound like static. Physicists cool the cavity to just above absolute zero to eliminate noise. They listen for weeks, months, years, scanning one frequency band at a time, tuning the cavity like a cosmic radio, sweeping across possibilities in search of a note that has never been played. Sometimes they find anomalies, spikes in the data, ghosts in the spectrum that vanish when re-examined. The results always return to silence, but that silence is meaningful. Each non-detection constrains the axion's possible mass, tightening the map of where it might hide. With every null result, the cage of ignorance grows smaller. At Yale, another experiment listens, Haystack, the haloscope. At Yale, sensitive to axion cold dark matter. Its magnets are smaller, but its ears are sharper. Quantum amplifiers cooled to near absolute zero, capable of detecting a single photon in a trillion. In 2025, they detected something, a faint excess of power at 36.4 microelectron volts. 2 standard deviations above background noise. It might have been a fluctuation, it might have been a whisper. The world waited, breath held, for confirmation. None came. The signal faded into statistics, but for a moment every physicist who had devoted their life to listening to silence felt something close to belief. Then there are the helioscopes, instruments that do not listen to the darkness, but to the light. The CERN Axion Solar Telescope, CAST, points directly at the Sun, searching for axions that might be produced in its nuclear core. If axions exist, they could escape the Sun's blazing density and, upon encountering the magnetic field within CAST, reconvert into X-ray photons. Day after day, the telescope tracks the Sun, following it across the sky, staring into the source of all life in hopes of glimpsing a particle that would rather remain unseen. So far it has found none, but its silence too has meaning. It tells us that the axions coupling to light must be weaker than we imagined, that the invisible is even more invisible than we dared hope. Soon, the International Axion Observatory, IAXO, will take the stage, a cathedral of precision larger than any that came before. When it comes online, its detectors will be so sensitive they could hear a whisper of light across the distance of the Moon. It will not just look for axions, it will listen to the very limits of possibility. Elsewhere, other approaches bloom. The ABRACADABRA experiment coils magnetic fields into toroidal shapes, like rings within rings, trying to trap axions as they slide through the Earth's magnetic domain. LUXZEPLIN and XENONNT, enormous vats of liquid xenon built to detect dark matter, now double as axion detectors. The same silence that hides dark matter may yet reveal it. Together, these projects form a global network of listening posts, straining to catch a single photon that would rewrite the laws of nature. It is easy to forget, amid the equations and the instruments, that this search is as philosophical as it is scientific. These machines are not just sensors, they are expressions of faith. They embody the belief that reality is not beyond comprehension, that even the quietest truth can be measured if one learns to listen correctly. The axion is not a loud discovery. It will not announce itself with a flash of light or a shower of particles. Its confirmation will come as a murmur, a single line of data rising above the noise, a peak in a graph that looks indistinguishable from background, except that it will stay. And in that small permanence, the world will change. What would it mean after decades of silence to finally hear the universe whisper back? Perhaps it would mean that nature's deepest secrets were never hidden out of cruelty, but out of delicacy. That truth was always speaking, but humanity had to quiet its own noise to listen. There is something almost monastic about these experiments, the devotion to precision, the refusal of haste, the reverence for stillness. Every calibration is a prayer, every frequency sweep a meditation on existence. These are the modern mystics of science, searching not for God, but for the equation that unites the invisible and the real. And though they may not know it, their instruments echo the very nature of the thing they seek. The axion is patient, it is subtle, it moves unseen through the world, adjusting what must be adjusted, ensuring that imbalance never grows too large. These experiments mirror that same patience, the quiet perseverance of those who seek equilibrium between knowledge and mystery. For now, the machines continue their vigil. A DMX hums in the dark, HAYSTAC refines its quantum amplifiers, CAST gazes toward the sun. Each day adds another layer to the map of silence, another boundary to the possible. Perhaps one day soon a signal will appear, a faint, unwavering tone at a frequency no instrument has ever captured before. It will be small, almost absurdly so, and yet it will mean that the axion is real, that the ghost of symmetry has been found, that the universe's invisible correction has finally revealed its hand. Until then, humanity listens. Because sometimes to understand the cosmos, one must not look harder, but listen longer. Next, we will step back from the machines and look again into the silence itself, into the paradox of discovery and doubt, where scientists must decide whether absence means failure, or if perhaps the silence is the message. There is a peculiar kind of beauty in not knowing, for in that uncertainty, discovery still breathes. Every great experiment in physics begins as a question, a small rebellion against silence. But with the axion, the silence is different. It does not resist. It invites. It stretches endlessly, as if daring humanity to persist long enough to hear what it hides. Decades have passed since the axion was first imagined. Generations of scientists have grown old waiting for a whisper. The data accumulates, the constraints tighten, and yet the result remains the same. Absence. No flash, no bump, no resonance, nothing, and yet not quite nothing. For in this absence lies a strange pattern, a narrowing corridor through which truth must eventually emerge. Every non-detection defines the universe more clearly, just as the spaces between stars give shape to constellations. The silence itself is structure. It tells us where the axion is not, how faint it must be, how quiet the whisper must sound. The search for the axion has become an act of meditation on the limits of perception. The instruments are perfect, the mathematics sound, the patience unyielding, and still the universe withholds its final word. This is not failure, it is intimacy. For to study the axion is to trace the edge of what can be known. Sometimes, late at night, physicists sit before their monitors and watch the live feed of data streaming in. It looks like static, random fluctuations, noise from the vacuum itself. But somewhere in that chaos, there might be a pattern no one has yet seen. They listen to the hum of superconducting magnets, to the faint vibration of the earth. Every sound could be the one. Every silence could be the threshold. At times, doubt seeps in. What if the axion does not exist? What if the symmetry it was meant to restore is corrected in some other, unseen way? What if all of this, the half-century of experiments, the hundreds of millions in funding, the whispered prayers of precision, is aimed at an illusion? But the idea refuses to die because it explains too much to be false. It resolves too many puzzles. The absence of CP violation, the nature of dark matter, the persistence of cosmic structure. The axion is the missing note that makes the symphony coherent. And so the search continues, not out of certainty, but out of necessity. The physicist Roberto Pece once said that the most remarkable thing about the axion is not its elegance, but its inevitability. It is as if the universe demands its existence. To remove it would make everything else less beautiful. And so humanity keeps listening, turning the dial of understanding one infinitesimal notch at a time. The silence has become a kind of map, each unresponsive frequency a coordinate in the great unknown. The ADMX experiment continues to sweep its spectral window, narrowing its search by fractions of a microelectronvolt each year. CAST keeps its gaze on the Sun, refining its limits with each orbit. Haystack tightens its filters, removing one source of noise after another, tuning closer to the ultimate quiet. Elsewhere, theory evolves in parallel. New models predict that axions may not exist alone, that they might belong to entire families of related particles, collectively known as axion-like particles, or ALPS. Some might be heavier, others so light that their wavelengths stretch across galaxies. Each variation preserves the core idea, a self-correcting field born to restore balance, but manifests it differently, like reflections of a single truth in distorted mirrors. And then there are the cosmologists, who have begun to suspect that the silence itself carries evidence. If axions fill the universe, they might subtly delay the arrival of photons from distant galaxies, or lens gravitational waves in ways so slight they appear as statistical quirks. Perhaps the proof has been there all along, in the cosmic microwave background, in the uneven clustering of galaxies, in the faint hum of space-time itself. To detect such traces is to read the universe's handwriting across distances too vast for comprehension. Each faint anomaly becomes a possible signature. Each unexplained deviation a reason to keep faith. But beneath the equations and the instruments, something deeper is at play. The axion has become a mirror for humanity's relationship with the unseen. It represents the conviction that truth exists even when it cannot be witnessed, that there are forces which govern reality not through power, but through balance. The human heart, like the axion field, oscillates between certainty and doubt, between seeing and believing, between silence and revelation. And perhaps that is why this search resonates so deeply. It is not merely about physics. It is about the act of believing in something that hides itself perfectly. There is a profound humility in this pursuit. The universe does not owe us answers. It reveals them slowly, conditionally, as if testing our patience. And patience in science is not passive. It is active devotion, a faith grounded in precision. Every moment spent listening to the silence of the axion is a moment spent affirming that the invisible still matters. That meaning does not depend on visibility. That absence can be eloquent. And yet even now, the silence trembles. A hint here, a fluctuation there. The Xenon 1T experiment once saw an unexplained excess of electron events, 3.5 sigma, enough to spark whispers of discovery. Later reanalysis at Panda X4T found nothing. The signal vanished back into stillness. But what if it wasn't gone? What if it was simply moving, changing, retreating into frequencies our instruments haven't yet reached? Every new generation of detectors extends our hearing by a little more. The next, IAXO DM radio, ALPS2, will listen at levels of sensitivity beyond imagination. The silence, they say, cannot last forever. And when it finally breaks, it may do so gently. A single photon, a faint line of power rising from the noise floor, an anomaly too persistent to dismiss, a murmur at the edge of perception. And then, just like that, humanity will have heard it, the first sound the universe ever made. But before that moment comes, there is the waiting. The slow realization that the axion's greatest revelation may not be the particle itself, but what its pursuit teaches us. That to explore the universe is to learn how to listen. Because in the end, the silence is not empty. It is full of questions, of faith, of the infinite patience of the cosmos waiting for us to understand. Next, we journey to the threshold of discovery, the point where the invisible begins to touch the tangible, where theory meets experiment, and where light itself might finally reveal the face of the unseen. There comes a moment in every great search when imagination and reality begin to blur, when theory, long held aloft by hope, begins to take shape in the laboratory light. For the axion, that moment may be closer than we think. To find it, scientists have learned to coax the invisible into revealing itself through its faintest possible gesture, a whisper of light. This is no longer physics as spectacle. It is physics as poetry, an art of precision so fine it approaches reverence. The axion, if it exists, can interact with photons through what is known as the Primakov effect, a process so subtle it defies intuition. In the presence of a strong magnetic field, an axion can transform into a photon, a quantum of light, and back again. The invisible becomes visible, if only for an instant, before dissolving once more into the void. It is this quiet alchemy that drives experiments like ALPS2 deep beneath the campus of DESY in Germany. The name stands for any light particle search, but its goal transcends the literal. In a long sealed tunnel lined with superconducting magnets and mirrors, physicists have created what they poetically call a light shining through a wall experiment. A powerful laser shines into a magnetic field, where photons might, if axions exist, convert into these hidden particles. The wall blocks all normal light, but on the far side, An identical magnetic field waits, hoping that a few axions will reconvert into photons and appear as ghostly flickers of light from nowhere. If even one such photon is seen, it will mean that the boundary between visible and invisible has been crossed, that the symmetry of nature has momentarily revealed its secret. To most people, this might sound implausible, even mystical, but to the physicists who built it, it is the inevitable extension of logic. The equations demand that axions, though weak, should leave traces in light. And so they listen, not to the roar of explosions, but to the silence between photons. Nearby, another project, DM Radio, takes the idea to extremes. It is a radio that does not broadcast, but listens to the vacuum. Inside its coiled magnetic heart, it waits for faint oscillations in the axion field to generate minuscule electromagnetic currents. Each possible frequency corresponds to a possible axion mass, and so the team tunes their detectors like musicians adjusting the pitch of an instrument, searching for harmony with the cosmos itself. These experiments are, in essence, acts of resonance. They are not trying to trap the axion, but to match it, to find the frequency at which human technology and cosmic structure vibrate in unison. When that moment comes, the universe will sing back. And that is not metaphor. The oscillations of the axion field are soundless, but they possess rhythm. Their waves, stretching through the galaxies, modulate space-time ever so slightly. To detect them is to hear the architecture of the universe resonating across billions of years. Imagine for a moment what such a discovery would mean. A particle smaller than comprehension, born in the first microseconds after the Big Bang, would connect the physics of the infinitely small to the structure of the infinitely large. It would explain why the universe contains matter at all, why galaxies formed in the patterns they did, why symmetry, so easily broken, still reigns in the nucleus of every atom. It would confirm that nature corrects itself not with violence, but with elegance. And yet, as profound as that realization would be, the true wonder might lie in what follows. Because if axions exist, they cannot be alone. The mathematics of string theory predicts entire families of axion-like particles, arising from the compactified dimensions of higher-order space. In that framework, every curled dimension, every unseen layer of the universe, gives birth to its own variation of the axion. These axiverse particles could differ in mass by 30 orders of magnitude, forming a spectrum that spans from the infinitesimally small to the cosmologically vast. Some could behave like dark energy, driving the universe's expansion. Others might condense into Bose-Einstein fields, forming halos that shape galaxies. The axion, then, may not be a single discovery. It may be the first note in an entire symphony of hidden matter. This possibility changes everything. If the axion exists, it bridges the two halves of physics that have resisted unification for nearly a century: quantum field theory and cosmology. It would show that the same mechanisms that restore balance in the atomic nucleus also sculpt the fate of galaxies. The correction of symmetry at the smallest scale would echo through the largest, and in that realization, we would see something deeply human reflected back at us. We too exist in duality, invisible within the vastness of space, yet capable of thought that spans galaxies. The axion reminds us that the smallest actions can define the largest structures. That correction, in all forms, is creation. There is a certain poetry to the idea that the universe's greatest mystery could reveal itself not through collision, but through harmony. Humanity has built colliders that mimic the violence of creation, smashing particles together at near light speed. But the axion will not be found in destruction. It will be found in resonance, in the still point where light, magnetism, and silence align. That stillness is not empty. It is waiting. And as these experiments hum quietly in the dark, perhaps the axion has already been seen in ways we have not yet recognized, in the unexplained transparency of the cosmos, in the polarization of starlight, in the faint cooling of dying stars. Light, it seems, has already begun to touch the invisible. We just have to realize it. When that realization comes, it will not be like the moment humanity first split the atom or glimpsed a black hole. It will be quieter, more personal. A single, unwavering photon will cross a wall it should not cross, and somewhere in the darkness a detector will blink. And in that blink, we will see not just the axion, but ourselves, the beings who built machines to hear silence and found within it the echo of creation itself. Next, we will step beyond the laboratory to the stars themselves, where nature's own experiments in the hearts of dying suns and the folds of space-time have been performing the search for millennia. Long before human beings built magnets and microwave cavities to hunt for invisible particles, the universe had already begun the search. It has been running its own experiments for billions of years, vast, fiery laboratories suspended in the blackness, where the laws of physics are tested to their limits. Stars. If there are any places in the cosmos where the axion might reveal itself naturally, it is within these blazing spheres of fusion and fury. For it is inside the heart of a star, under conditions of unimaginable density and heat, that the invisible is most likely to touch the visible. In the cores of stars, particles collide at near relativistic speeds, compressed into a plasma of protons, neutrons, and electrons so dense that a single teaspoon would outweigh a mountain. Within that chaos, photons struggle to escape, bouncing endlessly from atom to atom. It can take hundreds of thousands of years for a photon to travel from a star's core to its surface. But if axions exist, they can pass through that matter as if it weren't there at all. This is the first natural experiment. If axions couple even weakly to photons or electrons, they can be produced inside stars through processes like the Primakov effect, the same mechanism physicists use on Earth. These axions would carry away energy, cooling the star more efficiently than expected, and so by observing how stars evolve, how they brighten, dim, and die, astronomers can measure the invisible. It is an elegant form of deduction. If a star cools faster than theory predicts, something unseen is stealing its heat, and indeed many stars do. White dwarfs, those burnt-out stellar remnants that glow faintly after exhausting their fuel, cool slightly faster than models suggest. Globular clusters show anomalies in their stellar populations. Red giants seem to dim earlier than they should. Neutron stars, the densest objects short of black holes, radiate more energy than accounted for. Each discrepancy could be explained by mundane physics, or perhaps by axions quietly carrying energy away through walls of matter, slipping into space like ghosts. Astrophysicists have turned these stellar whispers into constraints. If axions couple too strongly to electrons or photons, stars would cool far faster than we observe. Thus, the very persistence of starlight tells us that axions must be weak, so weak that only the faintest interaction can occur. But weakness does not mean absence, it means patience. Some of the strongest clues come from supernovae, the most violent events in the universe. When a massive star collapses, its core rebounds in an explosion so powerful that for a brief moment it can outshine an entire galaxy. During that instant, the interior temperature exceeds 100 billion degrees. If axions exist, they would be created in staggering numbers, draining energy from the explosion and altering the signal of neutrinos emitted. In 1987, astronomers observed neutrinos from supernova 1987A, the only time we have directly witnessed such an event in our cosmic neighborhood. Those neutrinos matched expectations almost perfectly, and so paradoxically that agreement told us something extraordinary. If axions exist, their coupling must be weaker than 10 to the minus 9 gigaelectronvolts to the minus 1. The supernova's brightness and longevity were the universe's own calibration test, setting limits on the invisible. Even now, every supernova that flares in some distant galaxy adds another data point to the grand cosmic experiment, a whisper, faint but cumulative, building toward revelation. But perhaps the most poetic source of clues lies not in explosions, but in stillness. Consider the magnetic fields of neutron stars, fields so powerful they can bend the structure of atoms, twisting light into strange polarizations. If axions interact with photons, they could cause light from these stars to oscillate between visible and invisible states. Astronomers have found hints of this in the polarization patterns of certain neutron stars. The light emerging from their magnetic poles behaves oddly, as if something unseen is subtly rewriting its polarization mid-flight. It is not proof, but it is suggestion, the soft language of the cosmos. And then there are the black holes. These most extreme engines of gravity might also be testing the axion hypothesis on scales beyond our reach. If axions are light enough, they could gather around a rotating black hole in a quantum halo, extracting energy through a process called superradiance. The result would be a faint monochromatic gravitational wave, a ringing note in space-time itself. LIGO, Virgo, and Cagra are already listening for these notes. None have been heard yet, but the mathematics suggests that if such waves ever reach us, their pitch will correspond directly to the mass of the axion. The universe, in its own music, would be playing the song of the invisible. There is a breathtaking symmetry in this idea. Human beings on a small planet, tuning instruments to listen for whispers from their own magnetic fields, while the universe itself runs the same experiments at cosmic scale. Stars, black holes, galaxies, they are all detectors conducting their own version of the search. We are simply trying to read the results. In that sense, astronomy is not separate from particle physics, it is its reflection. Every time we look up, we are looking into the data. Every photon that reaches our telescopes carries the memory of processes that may involve the axion. Every supernova, every neutron star, every halo of dark matter is an experiment already in progress, its results written across the night sky. Perhaps that is the most humbling realization of all. The cosmos does not need our participation to test its own laws. It has been doing so since the beginning. We are simply the first species intelligent enough to understand that it is happening, and what the stars tell us softly, indirectly, insistently, is that something is out there, something that carries energy without light, that stabilizes chaos without force, that whispers between matter and nothingness. Whether we call it an axion, an ALP, or something yet unnamed, the message is clear. The universe does not waste symmetry. Every imbalance births its own correction. Every equation, no matter how broken, seeks closure. We are learning to read that closure in the language of stars. And so, as the light from dying suns flickers across our detectors and the gravitational waves of spinning black holes ripple through the void, one truth grows harder to ignore. The universe may already be showing us the axion. We simply have to learn how to listen to what the stars are saying. Next, we will turn from the celestial to the cosmic whole, exploring how axions might not just inhabit galaxies, but shape them, weaving the very structure of the universe from their invisible threads. If one could step outside the universe and look back upon it, not as a collection of stars and galaxies, but as a single living structure, one would not see light. One would see darkness with form. A cosmic web stretches across all of space, vast filaments of unseen matter connecting luminous galaxies like beads on a string. The bright stars, the radiant nebulae, the spiraling arms of galaxies. These are mere decorations. The real architecture is invisible. It is there in the web of shadows that the axion may be hiding. Dark matter has always been an act of faith. We cannot see it, but we must believe in it, because without it, the universe collapses. Galaxies spin too fast, clusters pull too tightly, and the cosmic microwave background, the afterglow of creation itself, bears fingerprints of a gravitational presence that cannot be erased. We have called this invisible mass dark matter, but that is a placeholder, a confession disguised as a name. It means we know something is there, but we do not know what it is. For decades, physicists suspected exotic particles, WIMPs, sterile neutrinos, hidden sectors, but each candidate has faded, undone by silence. And yet, in that silence, the axion has persisted, patient as always. Unlike WIMPs, axions do not interact through the weak force. They do not collide, scatter, or annihilate. They move through the cosmos like wind through glass, gently, collectively, coherently. They do not crash into galaxies, they become their scaffolding. Cosmologists now believe that, if axions exist, they may have shaped the universe in ways we can already see but cannot yet interpret. In the early universe, when temperature and density fell below the Pexiquin threshold, the axion field froze unevenly, forming domains of slightly different alignment. These domains, bound by filaments of topological defect, cosmic strings, became the first architecture of structure. Over time, as the field oscillated, the strings decayed into waves of axions, seeding the dark matter density that would later guide the formation of galaxies. It is an image both mathematical and mythic, the universe spinning a web from its own imperfections. Each filament of the cosmic web today may still carry the resonance of that primordial vibration. Galaxies form where those filaments intersect, drawn together not by the visible, but by the unseen gravity of axion halos. These halos are not solid. They are fluid, quantum condensates of the axion field, behaving like a single entity across light years. They may exhibit interference patterns, diffraction effects, even coherent oscillations over cosmic scales. Some simulations suggest that in such a universe, galaxies would not form abruptly, but would bloom from the intersections of these waves, like frost crystallizing on glass. If this is true, then the shape of every galaxy, including our own Milky Way, is the visible outline of an invisible sound. Within each galaxy, the axion halo extends far beyond its luminous edge, holding the stars in orbit, preventing them from flying apart. The stars are the notes. The halo is the instrument. In a typical spiral galaxy, visible matter makes up less than 10% of its total mass. The rest is this unseen scaffold. If those halos are made of axions, their gravitational fingerprints would reveal themselves subtly in the way satellite galaxies orbit, in the bending of distant starlight, in the timing of pulsars scattered across the void. Some simulations go further. They suggest that if axions are extremely light, around 10 to the minus 22 electron volts, they would not behave as particles at all, but as waves. Such fuzzy, dark matter would erase small-scale structure, smoothing out the universe on scales smaller than galaxies. And indeed, observations from the Dark Energy Spectroscopic Instrument, DESI, in 2025 hint at precisely this behavior.
It is as though the universe, at its largest scales, retains the smoothness of its beginning, a cosmic memory of balance enforced by the axion field.
Even more haunting is the possibility that axions could cluster into mini-clusters, tiny gravitational wells formed from fluctuations in the early universe. These clumps, no larger than asteroids but containing as much mass as entire planets, could drift silently through space, invisible but real, like pearls lost in a black ocean. If one were to pass through our solar system, it might slightly alter the orbits of comets, distort local gravitational fields, or even trigger faint electromagnetic signatures as it passed through Earth's magnetic domain. Some physicists have even proposed that transient anomalies in magnetometers or pulsar timing data could already be the footprints of these invisible visitors. And yet we would never see them. We would only feel them, in the way a sailor feels the wind, unseen but undeniable. What is most humbling about this picture is its symmetry. From the subatomic to the cosmic, the axion plays the same role. In the quantum world, it restores balance to broken symmetry. In the cosmic world, it restores stability to galaxies. The same mechanism that cleanses the equations of QCD also holds the stars in place. The smallest correction becomes the greatest structure. There is poetry in that. A particle invented to solve a problem smaller than an atom may explain the shape of everything we see in the night sky. And perhaps this is the deeper truth of the axion, that the universe is self-healing at every scale. It corrects its errors not with force, but with form. Its symmetry, once broken, is not destroyed, but refined. If we could see the cosmos through the axion field, it would not look like darkness. It would shimmer faintly, a slow ripple of invisible light running through every filament and cluster. The stars would appear as the foam atop deeper currents. We would see not emptiness, but balance, the quiet architecture of all things. It is tempting to imagine that this invisible web has intent, that it is not merely a structure, but a kind of memory. For the axion field is ancient, older than atoms, older than light itself. It has witnessed every cycle of creation, every collision, every extinction. It does not change, it sustains. Perhaps it is what allows the universe to remember itself. Next, we descend into the quantum itself, to the strange union of consciousness, matter, and the unseen, where axions begin to blur the boundary between the measurable and the metaphysical, and where the question arises: if the universe corrects itself, does it in some sense know? There is a point where physics begins to sound like philosophy, where the equations still hold, but their implications press uncomfortably against the edges of meaning. The axion lives precisely at that point, between the empirical and the ineffable, between mathematics and myth. If the universe truly corrects itself through this invisible field, then what is it correcting toward? Perfection? Balance? Or something deeper? Awareness? It may sound poetic to ask whether the universe knows what it is doing, but in quantum physics this question becomes unavoidably scientific. At the smallest scales, reality is participatory. Observation alters outcome. Measurement defines existence. A wave becomes a particle only when someone, or something, watches. And so when we speak of the axion as the mechanism by which the universe restores symmetry, we are brushing against a deeper paradox. Correction implies intention. The axion field does not simply exist, it acts. It enforces order on chaos. It senses imbalance in the strong nuclear force and adjusts it to zero. In that act of adjustment, of response, we glimpse something that feels alive, not in the biological sense, but in the metaphysical one. This is the edge where quantum mechanics and consciousness begin to mirror one another. Both are fields of possibility collapsing into choice. Both exist everywhere at once, and yet manifest only through interaction. If consciousness emerges from quantum systems, if thought itself is the resonance of particles within the brain, then we are, in some infinitesimal way, products of the same self-correcting mechanism that governs the axion. Every neuron, every synaptic firing, every quantum fluctuation that gives rise to thought is guided by fields that seek balance. Even within us, symmetry is preserved. Perhaps the axion is not merely a cosmic accountant, tallying the errors of the strong force. Perhaps it is the foundation of coherence itself, the invisible pattern that allows complexity to persist long enough for awareness to emerge. Because what is life, if not the temporary defiance of entropy? We exist because matter holds its shape, because electrons obey laws, because forces that should destroy each other find balance instead. The axion may be the reason that balance never collapses. Without it, the laws of physics would deviate ever so slightly, cascading into instability. Stars would not form, chemistry would unravel, time itself might become discontinuous, and yet here we are, stable, enduring, aware. That awareness too may be a form of resonance. The brain, at its quantum roots, is a system of oscillations and waves collapsing into meaning. When we think, we are not so different from the axion field oscillating towards symmetry. Both are feedback loops, both seek coherence, both are self-stabilizing. It is a strange and humbling thought. The same principle that steadies the nucleus of an atom may steady the fabric of consciousness. The physicist John Wheeler once said, "We are participants in bringing into being not only the near and here, but the far away and long ago." The universe, in this view, is not a static machine but a dialogue, a conversation between what is and what observes. The axion could be the whisper in that conversation, the link between the material and the mental, the physical and the aware. Consider what happens when an axion converts into a photon. A particle that was invisible becomes visible. The potential becomes perception. It is the same process that occurs when a quantum superposition collapses under observation. Information crystallizes into existence. In the laboratory, this is described by coupling constants and decay rates. In philosophy, it is the moment of becoming, the transformation of thought into reality. The language changes, but the essence is the same, unseen potential choosing to be seen. Could it be that the axion is the universe's way of observing itself? It is not consciousness in any familiar sense. It does not think or dream. But it acts in a way that mirrors awareness, perceiving imbalance, responding to it, restoring order. If awareness is defined as responsiveness to information, then even the simplest feedback loop partakes in it. In that sense, the universe is awake, slowly, quietly, and through mechanisms like the axion. And we, as fragments of that universe, are the extensions of that same awakening. Every act of discovery, every experiment, every search for the axion is the universe folding back on itself, seeking self-recognition. When we build detectors to hear the invisible, we are not merely observing nature, we are helping nature to observe itself more clearly. The axion, then, is not just a particle, it is a metaphor for knowledge itself. It is the unseen correction that makes understanding possible, and perhaps that is why it resists detection. The universe's most profound truths are often those that can only be inferred, never possessed. To find the axion would be to glimpse not just another layer of matter, but a principle, a law of self-knowing balance. It would mean that the cosmos is not merely a machine that happened to work, but a system that continually ensures it does. That realization changes everything. It reframes our place in existence. Because if the universe contains built-in mechanisms of correction, of remembering equilibrium, then destruction is never absolute. Every collapse gives rise to restoration. Every error births symmetry anew. We see it in the cycle of stars and black holes, in life and death, in thought and silence. And now, perhaps, we see it in the mathematics of the axion. The particle that cleanses the equations might also be the one that reminds the universe how to begin again. It is both matter and metaphor, a reminder that even the smallest things contain redemption. Next, we follow that thought to its ultimate consequence, to the idea that if the universe possesses such self-correcting grace, then the end may not be the end at all. Perhaps the axion's quiet balancing act ensures not only that the universe began, but that it can begin again. If the axion is real, then the universe may not be a story of beginning and end, but of rhythm. A vast eternal oscillation, correction, collapse, renewal, forever balancing itself between order and oblivion. We have long imagined creation as a singular act, a moment when nothing became everything, and time began its slow unraveling. But what if that was only one cycle in a longer pulse? What if the Big Bang was not a birth but a breath? The axion, born from symmetry, suggests as much. Its entire existence is defined by restoration. When the strong nuclear force threatened to break nature's balance, the axion appeared, an emergent solution, not imposed from without, but arising naturally from the equations themselves. It is as though the universe refused to tolerate its own imperfection and invented a new particle to correct it. This is not the behavior of a machine, it is the behavior of something self-healing. Imagine that principle scaled up, not just in quantum fields, but in cosmic cycles. If symmetry can correct itself at the smallest scales, might the universe also correct itself at the largest? Cosmologists once feared the heat death, a bleak future in which all stars burn out, all black holes evaporate, and space expands into silence. But recent theories, some invoking axions, hint that entropy may not be absolute, that the universe, even in its final stillness, retains memory. Here's how the idea unfolds. If axions truly permeate space as a vast field, their oscillations never cease. Even after galaxies fade and particles decay, the axion field continues to hum. Its frequency may slow, its amplitude may weaken, but it does not vanish. It carries the imprint of all that was, the symmetry of all interactions, the echoes of every correction ever made. Over unimaginable timescales, this residual energy could begin to reconfigure the vacuum itself. Tiny fluctuations in the field could spark new symmetry breakings, new energy gradients, new inflations. In other words, the axion field could reignite creation. The same mechanism that restored balance within the strong force could restore balance within the void. From the ashes of one cosmos, the first vibration of the next might arise. It sounds mystical. It may be purely mathematical. But the line between the two grows thin when one contemplates eternity. If this is true, if the axion field is both the universe's corrector and its memory, then nothing is truly lost. Every particle, every burst of light, every thought, every star contributes its pattern to the fabric of the field. When the next universe blooms, those patterns return, not as copies, but as resonances. The laws of nature are inherited, not written anew. The universe, in this view, is not reborn. It remembers itself into existence. This is what some physicists call cosmic recursion. The equations suggest that in the vacuum energy of a decayed universe, certain scalar fields, like the axion, can acquire enough potential to trigger a new round of expansion. Each iteration inherits the constants of its parent, modified slightly by quantum drift. The Big Bang becomes not a beginning, but a continuation, a wave cresting and breaking, only to rise again. And if consciousness emerges whenever complexity finds balance, then perhaps each universe gives rise to new forms of awareness, new ways for the cosmos to perceive itself. It is a staggering thought, that existence may be a feedback loop, a breathing rhythm of birth and correction, guided by something as faint as the axion's hum. In the quiet between the stars, between one age and the next, the axion field endures. It is the pulse of the eternal, too soft to hear, too subtle to see, but present everywhere. The same field that corrects the strong force in an atomic nucleus may one day correct the entropy of the cosmos itself. We may live within one breath of that rhythm now, one expansion among countless others. It is possible, too, that the axion's role is more profound still. Some theories suggest that it may interact not only with photons and quarks, but with the geometry of space-time itself. If that is true, then its oscillations might subtly alter the curvature of the universe over aeons, preventing total collapse or total dispersion. It would not be a savior, but a stabilizer, a cosmic metronome ensuring that expansion never outruns coherence. In that sense, the axion could be the reason why the universe remains habitable for thought, why stars form at all, why the laws of nature have remained fine-tuned enough for intelligence to arise and ask these questions. Because if the axion field keeps balance, then consciousness, our own awareness, might be an inevitable consequence of that balance. A natural result of a universe that insists on remembering itself. And perhaps that is why, even after billions of years, in a remote spiral galaxy on the edge of a common star, a species of transient beings built machines to listen for whispers in the dark. They were not trying to find the axion, not really. They were trying to hear the memory of the universe, the sound of balance itself. For if the axion field holds the blueprint of symmetry, then every sound, every heartbeat, every photon is a translation of that pattern. All of existence hums in tune with it, whether we recognize it or not. And when, at last, those beings realize what they are hearing, they will understand something vast and humbling, that the universe does not need to be reborn because it never dies. It simply changes key, The music slows, the notes disperse, and then, from the silence, a new melody begins. And through it all, the axion remains, the eternal chord, the quiet resonance that bridges one cosmos to the next. Next, we arrive at the final movement, the closing act where science, philosophy, and destiny converge. What happens when we finally find the axion? What does it mean for a universe to discover the mechanism of its own renewal? It will not arrive with fanfare. There will be no explosion, no cosmic trumpet to announce it. The discovery of the axion, if it comes, will begin with a blip, a single spike in a graph, rising slightly above the noise floor. The kind of anomaly a tired researcher might miss on the first pass, then pause, frown, and zoom in. There, among billions of data points, it will stand, a frequency that refuses to fade, a tone too steady to be random, too consistent to be illusion, light, born from nothing. In that moment, centuries of human longing will converge, our species' ancient desire to understand what it means to be. Because if that single photon is real, then so is the field that made it, the invisible lattice that holds galaxies together, the balancing mechanism that keeps the strong nuclear force pure, the echo of perfection that hums beneath creation itself. It will mean that the universe is not arbitrary, that its symmetries are not accidents, that the equations we have spent millennia deciphering are not inventions of our minds, but translations of something truly eternal. The axion will not just answer a question in physics, it will close a circle in human thought. From the moment our ancestors first looked at the stars and felt wonder, we have been trying to listen for what holds it all together. Every myth of order, every dream of balance, every philosophy that speaks of harmony between opposites, they were all, in their way, intuitions of this truth. The axion is that harmony made real, and yet, when the announcement finally comes, it will sound understated. A press release, a peer-reviewed paper, a graph and a confidence interval, perhaps a headline, evidence found for axion dark matter candidate. But beneath the technical language, the implications will reverberate like the birth of a new religion. Because the discovery of the axion would confirm that the universe possesses not only structure, but self-awareness by design. It corrects its own mistakes. It sustains balance without supervision. It contains, within its own laws, the means to preserve itself. That realization changes the nature of existence. The discovery will echo through disciplines. In cosmology, it will complete the picture of dark matter and show why galaxies form as they do. In particle physics, it will resolve one of the greatest unsolved mysteries of the Standard Model. In philosophy, it will demand that we reconsider what order means when order is the universe's default state. But in the human heart, it will awaken something older. A recognition that we are not observers of a detached machine, but participants in a living, balancing cosmos. Every breath, every heartbeat, every oscillation of an atom resonates with the same field that keeps the stars stable. We are, literally, built from balance. And that knowledge will be almost unbearable in its beauty. Because when we finally see the axion, not as a dot in a detector, but as a concept, we will understand that we were never separate from it. We have been surrounded by it, made of it, moved by it since the beginning. It is not a discovery, it is a homecoming. Imagine then the moment in the laboratory, the data confirmed, the controls verified, the doubts melting into awe. Someone, perhaps a graduate student, perhaps a veteran physicist, leans back, realizing the scale of what has just happened. They have heard the first whisper the universe ever made, and perhaps they will think of how long it took for that whisper to reach us, 14 billion years of expansion, cooling, coalescing, evolving, thinking. The universe had to build ears out of atoms, consciousness out of chemistry, patience out of suffering, before it could finally listen to itself. We were the instruments the cosmos built to hear its own song. And what does that song say? That creation was not a single act, but a constant unfolding, that every imbalance gives rise to harmony, that no law of nature exists in isolation, that even the coldest, emptiest vacuum hums with the potential for renewal.
The axion field, if we could translate it, would speak of persistence, of equilibrium, of the quiet grace that keeps all things from falling apart.
Even now, as you listen to these words, trillions of axions pass through your body each second. They move through walls, through stars, through space and time without resistance. They are everywhere, unseen but essential, like the rhythm beneath a symphony. When we discover them, we will not be adding something new to our universe. We will simply be recognizing what was always there. And maybe that is the real revelation. Not that we have found the axion, but that the axion has found us. That it has been patiently waiting since the dawn of time for us to quiet our own noise long enough to hear its hum. In the end, it will not be a scientific triumph alone. It will be a moment of reflection, of humility. The smallest particle will have shown us the largest truth, that the universe is not a cold equation, but a self-sustaining act of balance, forever correcting, forever creating, forever aware. And as we stand there staring at the signal that proves it, we will finally understand that the silence was never empty. It was a waiting room for revelation, the hum of symmetry, the breath of eternity, the voice of the universe remembering itself. The axion at last will have spoken. Thank you for joining us on this extraordinary journey through the universe here on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us where we unravel the darkest mysteries of space.